All right, so I received a question from somebody on page 269, number 73. And the question was really about Part B. Part A, find the population at t equals 5, 10, and 25. And that was just a matter of plugging in 5 for the time in both of these, or 10, or 25. And when you did that, you got, when you plugged in 5, hopefully you got 333 for the population. At 10, you would get 500. And then when you plug in the 25, you get 800. That part's easy. The second part of the question, what is the limiting size of the herd as time increases? And limiting size is a clue. They're asking, is there some sort of asymptote for this curve? Are there, does it level off someplace? And if you look at the curve in the book, you can see that it does start to level off. How do you find that asymptote? And we learned how to do this, and there's 3 things you have to look for, and I'd like you to refer to page 260 in the textbook. And there's 3 cases where you have to look at the exponent on the t. And in this case, first thing I want to do is multiply that out. So I'm going to rewrite the problem as 100 plus 60t over 1 plus 0.04t. And when you're looking for the asymptote, you look at the leading coefficient in the top and the bottom. And first of all, if the exponents are the same, you look for the leading coefficient, and the asymptote is just y equals 60 over 0.04. And if you figure that out, it's 1500. So the asymptote is the limiting size of the herd. The herd will get to 1500, and then it will probably start decreasing again. So again, remember, when the question is asking for a limiting size, it's meaning what is the asymptote, and then refer to page 260. There's 3 cases to look at, so you might want to look at all 3 of those cases.